Hi, my name is Alex Fleischman, and welcome to the video overview for the Wimshurst generator demonstration. Alright, so let's start this demonstration off. This demonstration will familiarize students with the Wimshurst machine and how it works. Students will gain an understanding of the properties of the machine and how charges on each head interact with one another. Alright, let's work through the procedure. First, place the Wimshurst machine on a table and briefly demonstrate how it works by placing the metallic heads approximately 2 to 3 inches apart and turn the crank. Allow the machine to create a spark a few times. One of the heads carry a positive charge and the other carries a negative charge of equal magnitude. Both heads are stationary, therefore to, in quote, relieve the electric force between the two heads, a spark is created. Students will learn more about this machine in the electric field demonstration. Let's continue with the procedure. Let's take a piece of cotton and tear it into a small piece. Then, place the heads of the machine far enough apart such that a spark cannot travel between them. Then turn the crank of the Wimshurst machine for about 10 seconds. Quickly drop the piece of cotton ball onto one of the heads of the Wimshurst machine. Then, observe as the cotton ball jumps back and forth between the two heads. Alright, let's go over some questions. We know that in a Wimshurst machine, one head has a positive charge and the other head has an equal but opposite negative charge. Why does the cotton ball jump back and forth between the two heads? Well, the cotton begins with no net charge and acquires a net charge when it is dropped on one of the heads. For the sake of the answer, let's assume it was dropped on the negative head. The cotton will acquire a net negative charge and will be attracted to the positive head. Once the negative charge on the cotton is strong enough, it will be pulled toward the positive head. The magnitude of the negative charge on the cotton is less than the magnitude of the positive charge on the head, so the cotton will gain a net positive charge. This is called conduction. This positive charge, when it becomes strong enough, will cause the cotton to jump back to the negative head, and so on, and this will repeat like a pattern. So why, after a long time, does the cotton stop jumping between the two heads? Well, the heads are too far apart to discharge the high voltage through a spark, so they need to do so through the cotton. The cotton will jump to another head when the charge it acquires is strong enough that the force pulls it across the separation between the heads. Through this process, the heads essentially discharge through the cotton, slowly transferring part of their total charge to the cotton to try to neutralize it. Eventually, there will be not enough charge on one of the heads to allocate to the cotton, so the cotton will not be able to jump anymore.